Okay, and we are live. Good evening, everyone. Just do a little check. Everyone can hear me. I can hear them. Everything's good. Yes, no, okay. How are we doing over there, honey? Good? All right, it's on the way. All right, good. So it looks like everyone can hear me. So a couple of things to knock out before we begin the discussion on the weather. A couple of issues. Good. We're good. The live chat for next week and the week after that will be on Thursday. So that'd be on, good evening card, that would be on the 13th and then the 20th. And the 20th is going to be a big live chat because on that live chat, I will be unveiling the winter forecast with the technical discussion and the overall discussion. So we're going to have a winter forecast discussion, which will also be launched on Friday morning. So Friday evening is going to be kind of like the big reveal and live chat discussion where I'll go over everything I'm looking at and break down all of the features and why I'm thinking what I'm thinking. And then premium members will have the technical discussion to go over, and everyone else, the public, will have the general winter forecast. So that's scheduled for the 20th. So that's going to be a fun evening live chat. And then the 21st is where I'll launch it also on the public as well. So it's going to be a fun period. And then we go back to Wednesdays as on the... actually, after that, we'll probably do the 27th as well, because the Wednesday after that is the 26th, which would be our wedding anniversary, which I'm sure we'd rather do something together rather than doing a premium live chat, right? Right, honey? Mm-hmm. Yeah. See, you gotta be careful. You know, my wife supports me in many things, but I'm pretty sure doing a weather chat on our wedding anniversary would probably not go over very well, right? Yeah, right? Yeah, definitely. Yeah, definitely. Because, it's important to go out and do things, So that probably be pushed up to Thursday as well. All right, so we got that out of the way. I hope to see you guys with those chats. So let's take a look at some information here. Okay, so our coastal storm is still sitting here, producing waves of rainfall. Somehow the Mets are continuing to play through this. Personally, I would have been like, look, I'm not getting my players hurt, but hey, look, they're winning 9-2, so that's good. So waves of rain continue to rotate through. Right now, Connecticut and Long Island are getting the brunt of it in our area. Also, you can include much of southern New England. We had an insane amount of rain around New Jersey. Anywhere between 6 to 10 inches of rain fell. Literally almost a summer's worth of rainfall fell over the region with this storm. And on one hand, because it was a long duration event that started essentially on Friday and continued on through Saturday, Sunday, Monday, and Tuesday, that led to the ability for the groundwaters to really absorb this rainfall and really help to lock in a nice rebound in the drought conditions that we've been struggling with. But what caused this storm to basically sit and spin? Well, first let me pull up the right satellite picture. It really comes down to the way that the upper level winds played here. What happened was initially Ian crossed Florida and then ran into a western Atlantic ridge that kicked it back into the Tennessee River Valley. Now, the jet stream, the polar jet stream, was focused well to the north, and the subtropical jet stream was focused well to the south. So essentially, the remnants of Ian got trapped in between these two jet streams. And because of a mid-level disturbance that was right about here, it interacted with the 850 millibar disturbance and rapidly transitioned into an extratropical low-pressure system and formed this cutoff low. Now, with the cutoff low in between the polar jet stream and the subtropical jet stream, it essentially meandered through Virginia and towards the Delmarva Peninsula until it finally got kicked off the coast. And while it was meandering and slowly cutting across, we continued to remain in an easterly flow with a constant stream of moisture coming right out of the northern Atlantic right into our area. The interaction of high pressure, because of the strong convergence and confluence with the polar jet stream over the St. Lawrence River Valley, allowed for cool air to get funneled in from the St. Lawrence River Valley in New England southward into our area. Meanwhile, moisture got driven in. Essentially, this pattern, if it happened in January, would have produced an epic winter storm. I can't say whether the coastal plain would just have rain or not, but I can say that just away from the coastal plain, this setup would definitely have produced several feet of snow in this scenario. The coastal plain may have pulled off a pretty good snowfall event as well, depending on the strength of the cold air transport and the dry air that built in. Oh, by the way, if I have a little coughing fit, I've been battling a dry cough for like 2 weeks now, so I do apologize in advance. See what I mean? Which is kind of like a rite of passage of fall for me. So every year I have the same issue. So it's not like anything. It's just because I get allergic reaction. But anyway, with this upper level low hanging around, that's why we got waves of rainfall. Someone asked me, is this because of climate change? No. This is a typical long duration event. This is how you get those cutoff lows separated. There isn't anything extreme about this scenario or something that really stands out to me is like, wow, we've never seen anything like this before. Precipitable water values are pretty much what you would expect for this time of year. So that didn't really stand out to me. As we get to the cold season months, any type of precipitable water value event above 1.92, that would be a signal for some sort of climate influence, because that'd be well above what you would expect in a cold season environment. So that's what you would look for. So I didn't see anything of that respect. The jet streams, that has been acting a little unusual. And let me pull this up here. Actually, here we go. Okay, so what we're seeing here in this pattern, and let me zoom in here, and this is just the observations. What catches me by surprise is not the formation of this. It's the fact that we're in a La Nina year, a La Nina season, and this is not a La Nina pattern. We don't have any robust southeast ridge. We don't have a weak subtropical jet stream. We have a robust polar jet stream, but nothing that signals a strong La Nina, or even a moderate La Nina. And you have this persistent upper level low developing right around the Aleutians to the Gulf of Alaska and moving back and forth. So that typically is something you would expect in a neutral year or an El Nino year, weak El Nino year. So that has had me perplexed as to what is driving that. And I have been working on data about the volcanic influence, as you know. That doesn't provide me all the answers. I'm looking at the MJO, MJO and also the QBO influences. That doesn't really give me a strong answer. So there is something that over the next 2 weeks I'm going to be researching and really trying to figure out what is it about the third La Nina that could potentially be far different than what you would expect from climatological La Nina. When you see, and I guarantee you're going to see this going forward with the winter forecast from a variety of sources, it's going to be copy-paste La Nina. That's not going to work very well, because copy-paste La Nina sure as heck didn't work very well with the tropical season, didn't work with the summer season. So I don't know why it would work with the winter season, especially with that La Nina weakening. So I don't want to jump to conclusions yet, because I still got another 14 days worth of work to do research and find out exactly how this is working out. But I will say that your textbook La Nina pattern is not going to be a feature this winter. I think we're looking at a hybrid here. And what catches my attention with the upcoming pattern is how the snow growth is acting here. Let's just go look at the climatological feature here. This is what's going on daily. And what catches my attention, I'm sure everyone notices Siberia, but this catches my attention. Why? If we see significant snow growth in northern Canada, especially around the Hudson Bay, I focused here. A lot of people look at here, but I'm more focused here, right around the Hudson Bay. Because our polar air masses and Arctic air masses, they get strengthened when they go through here. And if you have a lot of snowpack here, that acts like kind of like a refrigerator or a freezer, okay? It doesn't allow for any modification of the air mass. It keeps it pure. And if the forecasts are correct over the next 10 days, we should see well above normal snowfall happening right around here. And so the next 14 days is going to be an interesting indicator, because that will give us an idea on the type of air masses we're dealing with. But it doesn't give us an idea on the blocking that we might be dealing with. And that takes me to my next data here, which is our sea surface temperatures. So we've been talking about this for a while. Obviously, there's our La Nina. There's our weakening signal in the Indian Ocean. So we're seeing indications that our La Nina is going to weaken. We're seeing plenty of mild data suggesting that. But what really stands out to me is the well above normal sea surface temperatures in the northern Pacific and the northern Atlantic. How do you work with that? Because the signal that you typically would see for a negative NAO or a positive NAO is muted. Why? Well, let me show you why. You see this feature right here? Typically, if you have well above normal water here, you have well below normal cold water here. So if you have well above normal here, you get well below normal here. We're not getting that. Even in a negative AMO pattern, where you typically get a nice robust signal here, we're not really seeing that. Now, if you want to point to climate change on that, you could make an argument on that, technically, because this is the first time I'm seeing this type of signal really showing up in recordable data, okay? I cannot say whether that has never happened before, but based on what I'm seeing, this is the first time I'm confronting this for a winter forecast in 20 years. So it's got to stand for something, okay? So that really stands out to me. What we'll also watch out for as well, let me zoom in. See this cold water signal? This could be more due to the influence of Ian here. So what we'll watch out for is to see whether or not we get a quick rebound. Because if we do, then basically this is driven by upwelling and the influence of that persistent easterly wind, and then this will recover very quickly. So I wouldn't jump on this. I give it a week and see what happens. But this here, this has been supporting a lot of storms blowing up, not just tropical, but extratropical as well, right in this area, 50 north, 50 west. And that typically leads to a prolonged signal for a negative NAO. What makes it more complicated is that typically this area is below normal, so that gives you your thermal gradient, which enhances your storms and allow for your block here. This year, I'm not really seeing that. So it makes things a little bit more complicated. It's not a 1-to-1 ratio rule like you would see in other previous winters. In the Pacific, I'm dealing with the same issue here. Typically, I'd see a pure negative PDO or positive PDO signal. This year, I'm not seeing that at all. It's kind of muted everywhere. Because if I was seeing a positive PDO signal, then I'd get well below normal water here. If I was seeing a negative PDO signal, then I'd get well above normal water here. Instead, I'm getting well above normal water everywhere except for around the Aleutian Islands, which is enhancing our storms here. So again, another signal that I really haven't seen in 20 years. Just to be completely frank and honest with you. You know me, I tell you, if I see something that's unusual, I'll tell you about it. And this is kind of unusual. So if you're wondering, hey, why is it taking so long to produce a winter forecast? Why are we waiting to the 20th? Typically, I wait to the 20th anyway. But this year, and I said this before earlier in the month, early in September, this is likely going to be the most difficult winter forecast I've had to do so far. So I'm struggling with some of these factors and looking at research to see how to work that out. But in the meantime, some of the forcing parameters that we're going to be studying will basically evolve around the EPO. And right now the EPO is very negative. If we look at when I look at these teleconnections, I like using the ensemble guidance because when you use the operational, you get all this noise. Now, a lot of people like using the operational, whether it's the GFS or the European, because it shows extremes and everyone gets excited. You know, like you see this huge dip here and it gets everyone really amped up. But then notice all the noise that you get here. The reason why I like the ensemble guidance is that it kind of quiets that noise. It kind of reduces it. And so you could see where the extremes are, but then you see where most of the guidance is. So it kind of reduces that noise. So we are in a negative phase through much of this month, which keeps us with a trough generally supported in the east. On the 46-day forecast, it supports that as well, but then we go positive right towards the end of the month and for early portions of November. But notice we start trending negative again. What really stands out to me is what's happening with the Arctic Oscillation and the North Atlantic Oscillation. For 3 model runs now, I've been seeing this signal where as we move through November, October we stay positive, but as we move into November, we get more and more negative. And the lower bound, the extreme bounds, are getting deeper. So what is this telling me? Well, it's telling me that the EPO pattern, which is this feature here, when it's negative, this feature is back towards the western Aleutians, or should I say the eastern Aleutians and the western Gulf of Alaska. When it's positive, this feature is in the Gulf of Alaska. When it's positive, you get Pacific air flooding the United States. When it's negative, you see a ridge build up like you see here, and the ability for polar air masses and cutoff lows and all sorts of mess developing. So what I guess I'm trying to say is that model guidance is starting to pick up on the support for more and more high latitude blocking. I think for October, I think we've seen our stormiest weather. I can't 100% close out the tropical season yet, but this feature out here we're going to be watching very carefully. This is a tropical depression that, I'm going to spend 2 seconds on it. It's being sheared apart. Goodbye, adios. There's Tropical Depression 12. But this feature could be a development once it gets into this area. But right now it's dealing with far too much shear. But when I take a look at the forecast, let's see, I think it's this feature right here. Here we are. The Mjo Forecast here for the long range just is not really screaming much in the way of support for widespread tropical development in the Atlantic, which again is incredibly unusual for a La Nina that basically, based on the SOI, should be a moderate La Nina. We shouldn't be seeing this. That's the truth. So it's interesting to see all this data come together with our third wave La Nina, our triple dip, so to speak. It's not behaving the same way as the one in the 70s. So it's very unusual in that respect. So that's kind of the data I'm looking at here. I think that we've seen the worst of our rainfall events for October. I think from here on out we deal with more fast-moving cold fronts. The only wild card there is possibly another tropical influence through the rest of this month. So you can't ever rule that out. It would be foolish to do so. But overall, I see this as a drier weather pattern, cool weather pattern, where we moderate gradually back towards slightly above normal temperatures for the end of the month. So like Halloween, that time period looks to be kind of dry but warm relative to this time of year. So that's certainly something. I don't see any huge extremes going forward after this time period for the rest of October. November is looking very interesting to me. It's looking like a pattern, like a weather pattern that we should watch out for coastal storms, not necessarily winter storms, if you get my drift, not snowstorms, but certainly the potential for increased cyclogenesis and nor'easters. And it's going to be a bellwether for the upcoming winter, I think. That's kind of what I'm thinking right now for early November, but we're still fleshing that out. So those are my thoughts. Let me drop in here and start answering your questions, which it looks like you got plenty of.
Some on YouTube as well.
Oh, wow. Yeah, we are busy. Look at that. All right. So let's start off with the premium chat first, of course. Shockingly, the 18Z GFS is not spinning up our hurricane. Don't worry. It's probably just on vacation. Looking at the SPC site the past couple of days, it looks like there was some good atmospheric cooling going on in the storm. Absolutely. As the storm transitioned into a cold core system, it really intensified in terms of the 500 millibar heights dropping, and that allowed for rapid cooling at 850 millibars. But even with that, let me see if I can pull this up here. Here we go. It's been cool, but take a look at the cold air transport that's on the way with our cold fronts the next couple of days. This is some chilly air. We're talking about 30s in the Poconos and Catskills. I would be prepared for frost if you have any vegetation outside in northwestern New Jersey, Hudson River Valley, Hudson Highlands, basically, the Poconos and Catskills, especially for this weekend. There's some chilly air. I mean, that is some impressively cold air already coming into play here. And again, what really stands out to me is typically in this type of weather pattern, if it's dominated by La Nina, you would see a nice robust southeast ridge here. Sure, we might get clipped, but you'd see that robust ridge, and we're not seeing it. It's displaced off towards the plains, which is really, it's just kind of catching my attention. And this buildup of cold air that keeps on showing up in the guidance. I want to see whether or not this verifies on October 15th. But this really catches my eye because this will support an expansion of the snow shield. So yeah, there's a couple of signals here that just really like makes it go, you know? It kind of makes you step back and say, something is evolving here and we need to really keep an eye on it. Remember Dr. Neil Frank? He ripped the alarmists who are trying to claim that Ian's intensification impact were because of climate change. Well, it's an interesting discussion on climate change. There's the intensification of Ian. There's research on how the upwelling that occurs in these major hurricanes can at times cause a mesoscale gradient, which can enhance intensification of the hurricane in a unique process. Because they've noted in several of these storms you see this strong upwelling influence and this gradient that sets up, and then it basically develops the intensification especially on the eye wall, wherever that gradient sets up, that intensifies the eye wall. There still has to be some more research on that, but it would certainly go against the whole, well, it's just climate change. Because what this would show is that it's part of the process of these storms. Here's the thing. Hurricanes, warm core lows, there's still a lot we have to learn about warm core lows. And it's dangerous to jump to conclusions. So I'm very careful to say I have no data to support or refute the influence of climate change on these hurricanes, which is exactly what the IPCC says. So I'm not like saying something that's weird or out of the box. That's literally what it says, and it's because real scientists recognize what we don't know. And there are certain processes within the hurricanes that we don't know. We just, because of the improvement of satellite, we're starting to get a better idea of the vortices that develop within the eye wall. You notice, like recently, the satellite pictures, you zoom into the eye and you see these little vortices within the eye. Before 10 years ago, we had no idea that those existed. None. No clue. Why is that important? Well, those vortices might be key to understanding the intensification process and how those vorts interact with that thermal gradient that's found at the lower levels of the boundary layer at 10 meters could be an important indicator, could be an important factor, could be something that we don't understand. Now, let me play devil's advocate here, and let's go with the climate change idea. Okay. If you have a colder stratospheric environment because of the influence of CO2, then that would lead to an increase of 500 millibar heights, which would lead to ability for a tropical system to release and get rid of the latent heat energy. And that latent heat energy release would allow for a stronger engine. And so that engine is able to maximize its potential and therefore intensification of a major hurricane. So that is a potential climate change influence. What I'm saying to you is that we still need more research on it. Okay? So that's all I'm saying. Does that mean we shouldn't prepare for them or shouldn't, work on our energy infrastructure or any of that stuff? No. But I'm just telling you what the science is. And telling you something that isn't true leads to problems, because if we find out, if we learn that we're dealing with a different influence, then it hampers the research on climate. And unfortunately, I don't want to be a politician, but unfortunately, this topic involves politics for a variety of reasons. Pick them. And all I'm interested in is the actual science of it, not whether or not it's popular. Probably why I've always been a nerd. So, go figure. So, that's my point on that. The Earth is very complex, and in my opinion, all the climate models fail to capture the complexity correctly. Not all. I think they've improved. I think the initial ones were kind of crappy, but I think we've seen improvement. 700 millibar polar vortex looks like Darren Speedway in South Carolina. Oh, well, let's take a look at it. Okay. Let's take a look at that. Let's see it. You said 70 millibars. Okay. Now, we're talking about the polar vortex. This is in the stratosphere. Anything above 100 millibars, basically from 1 millibar to 100 millibars, is considered the stratosphere. And what's really interesting about the development of this polar vortex is that it's very stretched out. Now, a strong polar vortex, and we'll take a look at the next level up, which is 10 millibars. Strong polar vortex basically looks like a circle, or like a donut. So a weak distorted polar vortex is stretched like this, which is an important factor as we go forward. At 10 millibars, we see that same stretching here. So it's very interesting. Premium members, you know, when I discuss the snowfall that's going on in Siberia, why this is important. And we'll talk about this more on the 20th. Atlantic looks like it cooled off in spots towards the coast. Yes, that's mostly due to upwelling. In the ocean, so on the cool side, yes, it is. Southern hemisphere waters look quite cool. Let me just nail down this whole influence on the southern hemisphere. In terms of our weather pattern, it does not have a direct impact, or barely an indirect impact. Because of the equator, we're kind of separated from any influence down here. But certainly we have plenty of cool water, but, you know, that's not too unusual for this time of year. We'll see if that continues. But certainly something that is interesting. What is the state of the Aam and Qbo? Well, let's see here. Let's pull up some of that data. See if I can get to it. Okay. Let's see here. Qbo data first. Okay, it's currently, it was in a moderately negative state. Now it's nearly neutral at 50. Let's take a look at 30. And 30, it is in a positive state, but generally in a neutral state as well. So the QBO state, as we head towards the end of this year, is generally in a state of it looks like it's developing more of a positive state, which is pretty interesting in terms of potential for high latitude blocking. Usually a positive state supports, it doesn't support intense stratospheric warming, but it does support a sustained warming going on. So that's pretty interesting to see how that plays out. I know a lot of people like to compare some of the most intense winters that we've seen. 2009, 2010 was a season that featured a negative QBO state. And then, let's see here, 2010, 2011 was a positive QBO state. So you had two states, one negative, one positive, but they both featured some intense high latitude blocking regardless. The AAM, let's see if I can pull that data out. Angular momentum right now is currently in a negative state. "20 years is still a very short geological time and overall ability to provide the various data not available." Yes, all right. So yes, it is limited. I'm not arguing that. What I'm saying is that based on the data we have and the data we use for these seasonal forecasts, this is a unique scenario. And because I'm limited in data, that's what creates my uncertainty in the forecast. We all recognize what our limitations is in data. But what I'm saying is that based on that limitation and what we know and the rules that we have in meteorology, I can only work with what we have, right? And what I'm saying is that what I'm seeing is very unique. That's all I'm saying. Even the sun is doing weird stuff, reverse polarity. Yeah, but that's not too weird. What's happening now with the sun is typical of when we have more active sun. So it's not too unusual. I understand that 5 days out that the NHC had the track of Ian within 5 miles of actual landfall. They did a great job with the storm. Yeah, overall I think they did a great job. Do you see any potential for a tropical or subtropical system spinning up off of fronts that pass through and stall? So far, no, I really don't. I don't have any data to support that, so for now, I think we're good. If nights are clear and there is light winds, would not be surprised to see coldest Pocono spots get to or at below freezing. It's possible. Can't rule it out. Does higher solar activity also cool the stratosphere? It can, depending on the way that the activity is impacting the Earth's atmosphere. The reason why I'm pausing a little bit is that the caveat here is, how do we handle the well above normal water vapor in the 10 millibar area, and how that influences with the solar impacts, because that may cause more warming than cooling. So it's a bit of a wild card. The vast majority of politicians could care less about actual science. Well, I mean, that's true for everybody, but everyone likes science as long as they agree with it. Rob asks, Rob, a lot of interesting thoughts with your long-range thoughts. Do you believe we may have an earlier than usual start to winter, or do you feel it will be more back half winter like prior years? That is a great question that I'm working on. Typically, La Niñas start early and then end late and end early. So, like you get like a November storm or early December storm, and then March it warms up. But we didn't see that the past two La Niñas. Excuse me. So I'm not sure yet. That's one of the things I'm still working on. Off to YouTube. Let's see what we got here. Oh, we have a couple of things. Let me refresh and make sure I got all the questions here. Yep. Unfortunately, oh man, I see the new commercials they have here. Yuck. Let's see here. Okay. So let's see. Okay, Opie, I'm glad you're looking forward to this. How did the remnant low that was Hurricane Ian cause that many days? Because it transitioned into an extratropical low pressure system and got caught in between two jet streams. So when you have a low pressure system that's anchored around Virginia and the coastal waters of the Delmarva Peninsula and high pressure to the north, it just produces a persistent easterly wind at all levels of the atmosphere. And that leads to just constant rain just rotating right in. So that's what pretty much caused this rainfall event. Alicia, and I do apologize if I say your name wrong, do you think the PDO state will change to a positive one anytime soon? It looks like the models are showing a lot of ridging near the Pacific Northwest for the next 2-3 weeks. I think the state of the oceans right now are pretty much locked in. I would be surprised if I see any drastic changes. So I think we're seeing the pattern being driven by two features. The first is this thermal gradient here. And the second is what's happening in the stratosphere with below normal heights really starting a nice ozone building, which, let me pull it up. It should be this one. Here it is. See this feature right here? Nice area of ozone really building up here. I think that's really instigating our weather pattern and leading to this trough around Japan, or to the east, to the west of Japan, and this feature here. So that's allowing for your tropical systems to get lifted right up towards the Aleutian Islands and enhancing this trough here. So this feature here, I think, is helping to drive this fall weather pattern. What happens with the La Nina patterns the next year? That's what I'm kind of working on, thus the winter forecast. Could this winter be robust with snow? I don't know yet. And it might be more robust for portions of the coastal plain than the interior. It kind of depends on the type of storms that we're dealing with. So that's one of the questions I'm going to be working on in terms of storm tracks and storm types, stuff like that. So don't know yet. So I think I got all the questions. Do you see any other questions, hon? Okay. Let's see here. The volcano and the water vapor from it as such a huge unknown, because it is, simply put, something that has not been observed before. Exactly. Along with the sea surface temperatures that I haven't observed before. So those are two unknowns I'm trying to work on. Absolutely. I just want some snow on the ground for Christmas. Well, don't we all? But yeah, that's something that would certainly be nice. What I think is going to be a very important factor is the snow growth, not just Siberia, but in Canada. If we see this snow growth really take hold, that allows for your strong polar air masses. The past 2 winters, heading into the winters, we've seen scenarios where Pacific air would drive into Canada and just eat away at the snowpack, and you'd get this mild conditions cutting all the way towards the Hudson Bay, and that would essentially kill any potential of strong polar and Arctic air masses building south, right? So this year, if we don't see that, it kind of fundamentally changes the whole game. Good coffee.
I like it.
Yep. Let's see here. It is 8:41. I got 19 more minutes, and then we'll call it a night. But excellent questions tonight, guys. Excellent questions indeed. So if you have any questions, just continue to fire them, and I shall answer them. Taking a look at the pattern, because after this I will be doing updates for everyone and sending out an evening update as well. Well, let's walk through and see if there's anything major going on. This cold front on Thursday and Friday is really going to pack a punch, because not so much rainfall, but don't be surprised if Friday evening we're pretty windy, which could actually impact the Mets game, to be honest with you. Because you're going to get that strong northwesterly wind. Let's say I think the Phillies play in St. Louis. That they're going to be fine. High pressure and control, beautiful weather for them. For the Mets game, though, I would not be surprised if it's really windy from the northwest. That could bode well for pitching, but not so much for home runs. Interesting. So that's something that we're going to definitely watch out for. And then some really strong cold air transport. But I don't see any major storms really showing up here, or at least over the next 10 days. Just a lot of strong cold front passages with scattered showers. Think snow, indeed. Hey, look, I am 100% for snowstorms. I mean, I'll stay up for a whole day to track a snowstorm. You've seen it. I've done it.
I've been there with you.
Yeah, and been there with me. And I'll tell you one thing. I got some new toys to play with this year. One of which is that I'm going to be adding into a kind of like a live jump into on Twitter, where I'll do a quick live video just going over the radar data, and now I can pull up my image, myself, my beautiful self, scaring the hell out of people, and a radar image right next to it. So that's going to be fun. I'm really looking forward to doing that, and introducing more one-on-one content. So that's going to be a lot of fun. That could have an impact on the Rutgers game Friday night. They host Nebraska. Is Nebraska good? I'm kind of lost with college football these days. I know I've heard that Rutgers is getting better. See, I've kind of boycotted college football only because I spent 6 years in Oklahoma, and those people are crazy. I mean, there's 2 religions in Oklahoma. It's football and, I guess, Christianity. So when it comes to football, well, it's for some, but I can't do college football anymore. I literally saw a guy get harassed. He was a high school kid because he was wearing the wrong football T-shirt or something. Crazy. But yeah, I mean, I haven't really. Is Nebraska any good anymore? I don't know. It should definitely be stormy out there. Let's see. Nebraska is terrible. Rutgers has no QB right now and no offense. Defense is pretty good. Okay. I mean, they don't have any QB. That's disturbing. Ask the Jets. Maybe they might have an spare QB. Can you do that now? I heard that they changed that with college sports. You can actually buy players. I don't know how that works.
Probably been doing that.
Yeah, probably, but now it's more obvious.
It wasn't obvious before.
Well, it was more of a wink. You know, like, oh wow, he has a nice car, and
Sure.
and gee, I wonder where they
That
found.
wasn't obvious.
I wonder where they found all that cash in the trunk.
Look at that! His mattress exploded with cash.
Look like the Mets are in the ninth inning. I think they're going to win this final game. They're going to have 101 wins. I don't care what anyone says. That's a great season. Okay, so we didn't win the NL East. That's fine. We get to beat everyone else in the playoffs. That's great. I'm excited. I don't know. I'm pumped up. I'm looking forward to that. Good for Jeff McNeil playing out there. Good for him. So let's see here. Okay, YouTube is pretty quiet right now with questions. Let's see. We should get new information coming in on a tropical development. That looks like it's pretty quiet. There's our tropical depression. One last fire up. That's probably not going to last very long. There you go. And the Mets have won. There we go. So what are you guys looking forward to with the play? Anybody paying attention to the Major League Baseball playoffs? I know some of you are Yankee fans out there. Phillies too. Phillies got a shot to surprise the Cardinals, I think. Don't sleep on the Phillies. They can be very, very hot cold. And if they get hot at the right time, they can be pretty dangerous. Let's see, and the water vapor. Now, you know what else stands out to me with the water vapor? Now that I think about it, now that I'm looking at this right now. Notice the development of all of these upper level lows. That's kind of unusual considering the AM is negative. You know, it's very... You're right. The Western Atlantic Ridge has been underwhelming. It certainly hasn't been as robust as I thought it was going to be. And that kind of caused issues with the summer forecast, by the way. That I thought we'd see more rainfall because I thought we'd see a stronger gradient and kind of moisture getting drawn up the coast. But that just didn't happen. Instead, you got usually this troughiness right around here that kept all your storms out here. And we stayed relatively dry. So that was really unusual. But now, as we move through fall and we get more and more of an influence of a thermal gradient in place, the number of short waves that are cut off into upper level lows has been above average for early fall. And we're seeing, again, these type of features here in the subtropical jet stream we should not be seeing in a La Nina. This should be very weak, and it's not. It just simply isn't. And these short waves are getting robust. And so what kind of makes me pause here is that when I see this type of signal showing up in the observations in the satellite data, it opens up to me the possibility of dealing with more phased systems in the cold season in November, December, January, and February. And you could even throw in March. And phased systems can be very volatile. You can end up with the influence of storms that phase at just the right time and produce massive snowfalls for all the East Coast. Sometimes they phase a little early and you end up with this cut up towards the Great Lakes, which leads to a massive rainfall event for the coast and maybe some icy conditions over the interior. So it really comes down to timing and how that all works out. The strength of the subtropical jet stream contributing to the cutoff lows. Yes, there is that factor. And in fact, let me show you this. Where is it? There's our upper level winds. Okay. The difference between these winds in the subtropical jet stream and the polar jet stream can cause a basically a spin up and a cutoff, and that's how these cutoff lows start to get kind of separated from the core jet streams and cause these type of major rainfall events that we've been dealing with. So it's certainly a factor, absolutely, and it's a potential indicator of that evolution. What controlling the moderate La Nina pattern in 2022? Well, La Nina is an influence of the winds and the pressure in the tropics. So there's nothing that controls La Nina. La Nina controls the weather pattern normally. This is not the case this year. I don't see it. Typically, what you would study is the SOI, which is your pressure difference, and this would give you a good gauge on how La Nina is influencing the pattern. But this signal does not match up with what we're seeing with this water vapor image. So it's a bit, again, this year's been a bit of a wild card and unknown, and it's been a very unusual year, to say the least, in terms of what we typically would suspect with tropical forcing. It certainly has been an unusual year, to say the least. So the evolution of any ESNO state is driven by sea surface temperature gradients. So again, what happens is that you get a change in the winds, your trade winds, that pushes this water away, allows for what we call upwelling, and you get this cold signal. In El Niños, you get the winds that blow towards South America, allows for a buildup of warm water, and that's called a El Niño. So it's driven by pressure differences, low-level thermal gradients, and how that feeds back on itself. But outstanding questions tonight, guys. Those are some really great questions. Okay, it is 8:52. I'm going to cut it down for tonight because I got some work to do. Get all the updates out for this evening, so I'll be sending those out and also updating the long range thoughts too. I have some work on that to do, so we're going to dive on that. Thank you again for, as always, coming in and visiting this live chat. Are you saying no El Nino 2023? I'm saying I have no idea what 2023 is going to hold. It could be neutral. So I have no idea whether or not we're going to be dealing with an El Nino or La Nina or what. I don't know yet. Well, probably not La Nina. I had never heard of 4-dip La Nina. So that's it for tonight. I will be back next week again on Thursday. And we're going to be 1 week closer to the new winter forecast. Have a wonderful evening. And as always, stay safe out there.